Okay, hello everyone. Welcome to the CI/CD deployment session, which is a customer story. And my name is Andries Demont. I'm working for the Belgian office as a sales engineer.
Yeah, and my name is Jelle, Michiels, also sales engineer in Belgium.
Yeah. So today we are going to bring you a customer story of a CI/CD. We are going to talk about a customer story. And in order to do that, we are going to talk about the project that we want to help. And then we are going to take you on an Agile journey, explaining on how the code propagates from a developer right into production, passing a number of stages. And last and not least is, of course, how we can configure such a CI/CD deployment pipeline.
Yeah, so regarding the benefits that you'll receive is that we will discover an agile way of working and view CI/CD pipelines based on how the customer in the Netherlands did it. And how they use those CI/CD pipelines to test and deploy application based on IRIS. And most importantly, we hope that you will be able to generalize from this and learn how to roll out features more comfortably.
So about the project. The end customer is Palga, which is a national organization in the Netherlands, and they serve about 50 pathological labs. And one of the goals of Palga is to enable the labs to retrieve each other reports using a national network. The integrator working on this project is ICT Netherlands. ICT Netherlands is active in most of the EU countries, and it's actually a big integrator. They're active in multiple domains, of which one is healthcare. And the project itself is Mercurius, and the task of Mercurius is to replace the legacy network of Palga. The legacy network is working with centralized data, one database in the middle, but as the GDPR came along, legislation changed, and now it's not possible to do that anymore. So they need to distribute the data at each lab. So each lab will be responsible for its own data. On top of that, they want to use the modern medical standards such as FHIR. And as they have to support the system for more than 10 years, they decided to go for CI/CD. So what is CI/CD? What is continuous integration and continuous deployment? Rather than showing you the definition of Wikipedia, I'm showing you what the customer stood by it. And basically, they want to remotely trigger a fully automated and qualitative upgrade of one lab, but also to be able to deliver an emergency upgrade of all the distributed systems in just 1 hour. And remember, it are about 50 labs and some central nodes that are there. So in order to give you a good grasp on how that works, we are going to take you on an Agile journey. First step when you go on an Agile journey is to meet the team. So here I defined a number of persons that are working in the Palga project. The actual team is much bigger, but those 4 will do to explain the process. We have Johan, who is a team lead. We have Twan, he's an integration tester, so he rewrites scriptable tests. And then we have 2 developers, Patrick and Maya. And using those 4 personas, we're going to explain you how it all works. So suppose we're Monday morning, 10 o'clock. Typically, the team comes together and they do a daily stand-up. Something typical for Scrum. It's a short meeting of about 30 minutes in which everyone explains what they did on Friday, on which they are struggling, and what the plan is for today. So Johan prioritized the sprint board, and he leads the meeting.
Yes, and so here you see the sprint board in Azure DevOps. So they use Azure DevOps for their Scrum management. And you can see the product backlog items there that they want to pick up during their sprints of 3 weeks. And all those product backlog items are divided up into tasks. And now Maya, one of the developers, wants to take up a task and implement the task. And for that, she will go to her own developer environment. And in the developer environment, She has a virtual machine with Linux on it. This is done so that all the other developers actually have the same environment. And there she will start working in Visual Studio Code. It actually makes a connection to the virtual machine. And in Visual Studio Code, there are a certain number of extensions. One is, of course, the Git extension for the source control. Another one is a Docker extension, as they use containers to deploy their application. Besides that, there's a .NET extension, as originally all the developers in the team have a background in .NET, and some parts in the project are actually implemented in .NET. And then finally, of course, there's an InterSystems extension. There's one that has language support, but also there's one that allows you to make a connection to IRIS instance and import and compile code into this instance, but also suppose you create a business process in the management portal to export it back out of there and to get it into Visual Studio Code. So she picked up the task, and in Visual Studio Code, she created a branch. She will start implementing the task, implementing the feature, and she can make commits. Then she can also push it to the online repository so our other colleagues can see the code changes. But when she's happy about the code, she wants to merge the code into the master. And for that, she creates a pull request.
Yeah, and a pull request is something that she does not do directly on her machine. She's going to use Azure DevOps for it. So there she creates it, and then a whole bunch of things are initiated. Inside the DevOps, there will be a branch policy configured, and basically it will check if the level of quality of code is good enough. First check, of course, is does the code compile? Are the unit tests full? Because as Maya wrote code, she also has written a unit test, but also did she link the task on the task board to the code check-in. And Azure DevOps is going to check that. But then comes into play Patrick. Patrick is one of the other developers, and he wants to do a manual check of the code that Maya has done. So he has the tools also in Azure DevOps to see what did she change, and has the possibility to add comments. And only when Maya and Patrick agree that all comments are resolved, the last check of the branch policy is actually green, and we can continue to go to the merge. So on this slide, we explained the whole process. So it was kicked off by Maya. She created a branch, developed, pushed it to a central feature branch in which Patrick could use Azure DevOps to give his comments, maybe initiated a number of feedback loops, and in the end, when everything was okay, the code got actually merged into the master. But that's not enough. We also have Twan. Twan is in the integration tester, and he wants to see that the architecture as a whole still work on a functional level and on a technical non-functional level, such as security. So he is going to kick off another script because he wants to see it working on a test environment. And the test environment is going wider, where the unit test is only checking a little part of the code on one container. The test environment is going to launch a number of virtual machines, and each virtual machine can have one or multiple containers. So how does that work? The code is already in master. In a first step, we are going to use Docker to build the code and make a Docker image of it that can be registered in the Azure DevOps container registry. In third step, we are going to deploy it. We are going to use some scripts that are still on the Git and combine it with the images to have a specific test environment going live. And then we have the integration tests. So that's an external tool that Twan used to define a large amount of tests, much more than the unit test. And actually, it will take much longer to test them. But in the end, we get feedback. And that's where it's all about. Is that enough? No, because the end customer didn't have the possibility to check the code. So we're going to create another environment in which the end customer can verify that the feature is actually what they wanted. And that is typically initiated by the team lead, Johan, in this case. Are we there yet? No. We still want to do one extra thing before we go to production. We are going to do stress testing. And stress testing is typically something you do on an environment where you are dealing with the same hardware or machine properties as the real production machines. So, and that's typically also more a team effort. It's not something that they do each day, but they have the possibility, they created a pipeline for it. And if all flags are green, the pre-production environment didn't give any issues anymore, Johan feels comfortable to push the button and actually launch it to go to the production environment. But take into account that it is a distributed system. We have systems in the lab, we have central parts with some archives. We don't always want to deploy everything, so there should be parameters that define specific components to be upgraded. So if we bring this all together, we have a nice architectural overview, and we see, again, it was initiated by Maya, first level of feedback, unit test, but also manual code review in the early phase. Then we got very thorough testing of Twan in the integration testing part. And the fourth level is the customer tests, stress testing. All that gives us a lot of possibilities to find bugs even before we go into production. And as a bug before production is only 25% of the cost of a bug in production, that's a huge gain.
So, okay, now we've seen how they go on as a team in their daily life, actually, in the daily work life. And, but of course, there were some design choices, some configurations they've done to make all this possible. And the first thing is they use containers. The reason for that is that it will be easy to deploy those. Another part is, of course, the test plan, and then to glue this all together, the deployment and the testing, they have configured pipelines. So if we look more into the containers, they're actually natural building blocks for applications, you could say, as in that they are lightweight and only contain the necessary components to run the application. But also you have the separation between code and data. So if you want to deploy or do an update, that makes it really easy. And in addition to that, you can easily move between all the different environments we just went through, and also configure the containers based on the environment you're on. So if we look on the next slide, we just see a simple example of a Docker file used to actually build the image. So you start from the base image of InterSystems IRIS for health. They've added their application code, some scripts they use, and then they go to an entry point application, namely the IRIS main application, which is responsible for starting and stopping the container, but also it performs a merge. It merges the configuration parameter file. Again, this is done so you can have different configurations for different environments. And for instance, on the right, we see one of these merge files. And so they changed the amount of memory that is allocated to the globals, but also on startups, they've added a password hash. Otherwise, the container would use the default password of sys. But at the end of the Docker file, they also have added startup scripts. And these startup scripts are actually, we see that on the next slide, execute some Linux commands. But they also make it possible to actually call the IRIS terminal. And in the IRIS terminal, they will perform some object scripts commands and use that to create actually namespaces, web applications, create users and roles, and so on. And also, they will load the production settings and start the production using these startup scripts. And here on this slide, we just see production definition. So if you go into the management portal, you can add components such as services there. But you could also, then again, that actually creates a production definition, and you, using Visual Studio Code, the object script extension, you could export this back into Visual Studio Code. And then below that, we just see the system default settings. And actually, for each environment, they have a different XML file specifying the settings for components in the production. And in the startup script, this is also applied to IRIS instance. And it's used to differentiate actually between the different environments. So for instance, on the developer environment, you want to have a timer that has a setting of 5 seconds, but in production, it might be a setting of 90 seconds, just because it's in the real world. And the developer environment is used to, to test something faster. A second part in this are, of course, the tests to get the feedback at each stage. And one part of that are the unit tests. In IRIS, it's possible to create classes, unit test classes. And to execute all these, you just have to set a global that points to the folder containing all these classes when a certain command and all the unit tests will execute. And in addition to that, there's a code coverage tool on the Open Exchange platform. And there, that basically will test if your unit tests actually cover the code that you've written, which is also important. But of course, this is not enough. You also want to test if the components on their own work with each other. So for that, one has written integration tests. He actually writes those tests before the feature itself is implemented. So they definitely think ahead with this. Also, they have system tests to check the functional requirements and some tests to check security, so the non-functional requirements. And they've built all this in .NET. And then the third part of it is, of course, gluing everything together, the pipelines. Pipelines is actually just a sequential description of all the stages you want to go through. And in this case, this will be a deployment stage, well, a build stage, a deployment stage, and a test stage, for example, for the test pipeline. On the next slide, we just see the YAML file for this. So where you define all the stages, all the steps in these stages, and the steps could be just script, just a line of code you want to execute, so Linux code. Or it could be also tasks that are already available in Azure DevOps. So tasks that are regularly used, such as a build and push of a Docker image, for example, as you see here. And on the next slide, we just see the second stage after the build stage. You want to deploy it. So the stage actually, you would add a key depends on. So it depends on the previous stage. Otherwise, those stages would run parallel. And then again, you just add a step, which is basically a task already available in Azure DevOps, doing the Docker Compose up based on a Docker Compose file. And on the next slide, we see how they use it at ICT Group. We actually see the PR pipeline, 2 stages, build stage and deploy stage where also the unit tests are run. This takes about 10 minutes. So it's really to get the quick feedback before you want to merge your code into master. But then if you look on the next slide, you see the test pipeline, some more stages, but you also see it takes about an hour. So it really executes all the system and integration tests to get your thorough feedback before you want to go to the other environments such as acceptance and production, of course.
Okay, so it's time to wrap up. What did the customer learn in this project? As the project started, they had to do a lot of scripting to get the first pipeline running, but as the project evolved more and more, the team became more mature and there is less and less effort to maintain those pipelines. But it's important to have the right profiles on your team. In the end, you always have to deploy a system. So rather you do it automatic or you do it manual. But in this case, you need someone that is able to script this all the way, and that might be an extra profile that you need in your team or an extra skill that needs to be there. During the process, they also learned that feedback to come fast is actually great, but if you are writing so much integration tests that the feedback is coming after an hour, when you really push that button to launch the test, sometimes you want to have it much faster. And that's why they decided at a certain phase that they had nightly and daily builds. Nightly builds to have the complete testing, daily builds to at least have the basic feedback and to continue. As they became better and better during the writing of the pipelines, they were starting to reorganize the YAML code, which led to much lesser code because they were reusing files and scripts in order to do that. And if they would have the chance to restart the project, they would actually set up all the pipelines right away, or at least heavily think about what is the latest stage in my production pipeline. Because if you are just working on Azure DevOps and the virtual machines there, that might be a complete other environment than the system of a lab that is being offered. So the faster you have your pipelines all set up and running, the faster you can also bring features afterwards to production. And so you are much more agile and you can react much more fast to the demands of the customer. So the key takeaways are basically the following. The first step is, of course, IRIS is very well suited for CI/CD because it's 100% scriptable. And the combination with containers makes it possible to reduce the number of lines in the pipelines because there is a lot of Docker automation already there. For the CI/CD flow, we see a lot of advantages as well. Because of the multitude of feedback, the quality gets much higher. Much more bugs are detected before they go to production. At the same time, it comes with a configuration cost. We cannot deny it. You need some other profiles, or you need to upskill some people. But we think that the return on investment is huge, especially if you have high deployment costs. Another advantage is that you can go with the feature much faster to production, and because of your code being much more reliable, the stress in the team is also lower. And the scalability. Adding one extra lab using CI/CD pipeline is really not that much effort. So that's basically the key takeaways that we have with that customer. Just to remind you, this is how the customer did it. We are not married to some of the tools that have been used here. It's just an example of how it can be done. And that's actually the presentation that we have. If you have questions now, please ask them. And if you think about something later, here are contact details. Maybe the micro?
Unfortunately, I'm not agree with a lot of pros you said here, like about one of the page said about lightweight Docker images. Not. Did you see the size of IRIS for Health Docker image? It's more than 3 gigabytes. It's not lightweight. It's a huge, okay, yeah,
I get it.
It's not a, like a point here, but yes, we are speaking about CI/CD here. 100% scriptable environments. It's not so simple. There are few ways how to achieve it, and it's not fully from like core IRIS with some external tools and so on. Easy deployment, yeah, it's not for IRIS, it's for containers means, but kind of. But the issue is that when you deploy your application with IRIS, it's like you have to first stop your previous container and run then IRIS. But it takes a while, so it will be like some interruption between when it stops and runs. It also, you have to keep in mind that your system will not be available for some period when it's deployed. And if it fails to deploy, you will have no system alive. And it's very important to check. About tests, you showed that like some percent of tests passed.
Yeah.
It's not for object script. For out of the box, you can't show this value. It's just nothing. It just have no way to get it. You can get like it's failed or not.
What do you mean with the last? No. So the percentage on the slide with the test plan.
Yes.
Yeah, that's actually.
Yeah, but before we go into technical details, it's the main philosophy that we are talking about. Of course, if there is a test that is not completely running or can be detected running or whatever, it is the main philosophy that you can automate your unit test using other tools, that you don't have to put much effort in it, and you get the feedback.
Speaking about object script, we are still IRIS. We also testing object script, but object script tests.
Okay, but I think we're not talking about unit testing. That's not the focus of this session. The session is actually to make the people think about changing the way of working. You could use containers. Actually, you can use scripting without containers and use those pipelines as well. So the customer made some choices. The customer chose Docker. The customer chose a .NET framework to test. But the main philosophy is that they get much better feedback with this system than they had before. And that's what is actually driving them to continue with this program.
I really like that you speak about CI/CD, and I'm like one of them who started to speak about it on developer community, how to use it. And I use it in many IRIS projects, also tests, also deployment, everything. And you can see many GitHub repositories with these examples. We covered all of this, but just few points about presentation.
Okay, thanks for the feedback. Okay, so if there are no other questions, then we would like. Sorry.
I'd like to stress, make a point on what the customer was the customer satisfied doing this? You already said, but how did the team work? I mean, did that change the culture? Was it a cultural thing too?
ICT Netherlands had already some experience doing that, and they started with the right profiles from the beginning. So there was no really, how do you say? They were not blocking this. They were open to it, and actually now everyone sees that it's actually a way also for the developers to have less stress. Because you can much more be comfortable about your own code. And for instance, a code review in that team, that's not something they go over easy. You check something in, and sometimes you think, okay, is this really a comment commenting, and it takes them maybe a bit more time because you need to negotiate or have that discussion why you did it or not, and it takes time, but in the end it improves quality. Yeah, that sir has a question.
What happens to the process if there's a failure that's detected very late in the pipeline?
But yeah, if it's not on production yet, it will typically be a bug that will be registered in the Azure DevOps sprint board. And if it's a critical bug, someone will immediately take it up. If other developers are blocked by it, then the priority gets higher. And actually, there is a team lead who will decide which has the priority. So yeah, it all depends on which level and how much impact there is that will define the priority. I don't know I don't know exactly what the rules are in this project, but typically each organization has a number of rules that defines, okay, that much impact, that much users involved, okay, then we need to do this. But mostly it triggers a bug, and then the priority is decided.
We use a very similar setup to this, and it works very well, but we don't use Dockers. We just pull the code from GitHub and compile in live when we release. But the question was, when you have a bug that's detected very late in the process, we put that in a release branch. We use the Git flow methodology, which identifies anything that happens late should be fixed in a special branch called the release branch that doesn't affect the development branch or master.
To be honest, they just, at this point, the production pipeline is there, but official go to production has not happened yet. So the actual first event to have a critical bug, a release is not being made yet. So actually that might be one of the extra pipelines yet, but they were working with containers, so in the end it should be a build of another branch that we are going to push on that Azure repository and then use that in the pipeline. Okay, no more questions? Okay, that means that we are on the end of our session. Thank you for your attention.